Welcome everybody, and thanks for coming. So my name is Sean, and I'm with the Colossal Fossils Natural History Museum out of Wausau, Wisconsin. And today's program is going to be about Ice Age giants. Before we get to some of the giants, the Ice Age is a really neat period in time for us to discuss because, well, our ancestors lived there. All of you watching this today, your ancestors lived during the Ice Age and the Stone Age. We are essentially Ice Age animals ourselves. And so as we go through the program, we're going to be talking not only about some of these Ice Age giants, but about some of the people who would have seen them. As you can see, I'm sort of dressed for the part here today. What I do for the museum primarily is what we call experimental archaeology. So I take artifacts from our ancestors, from people during the Ice Age, and I make replicas of them, and I take them out and I use them to try and figure out how our ancestors were able to survive alongside some of these great, huge animals. Now, first off here, I want to take a quick look at these couple of photographs, because unlike dinosaurs, our ancestors were actually able to see and interact with, and in this case, paint from living examples of just about every creature that we're going to be talking about here. Now, depending on where you are in the world, there's more or less cave art like that. Some of them are very detailed, very extensive. Some of them are their own styles. And the really neat thing about that is that the things they were painting are things that they were seeing. Like the mammoths on my headband here come from a cave painting out of France. The people who made that cave painting actually saw those animals in person, and along with finding occasionally frozen individuals that have come out of melting ice in the Arctic, the edge of the North Pole. We really know a lot more about Ice Age animals and Ice Age life than we do about even the Cretaceous, the end of the dinosaurs. Now, the Ice Ages got started with an environmental shift that happened about 2.5 million years ago. Now, at that time, our ancestors weren't really painting anything yet. They were still pretty small. Now, this is an Australopithecus skull. This is a replica of a very famous skull, an individual that was named Lucy, after the song Lucy in the Sky with Diamonds, because when they dug the skull up and were cleaning up the bones, that song was playing on the radio and they liked it, so they named her Lucy. Lucy here is probably a direct ancestor of us, but around 3 million years ago, just before the Ice Ages got going. She would have stood about yay high, around 3.5 to 4 feet tall. She wouldn't be very big, probably about the same size as some of you watching. Now, at this stage, she was still covered in fur. She would have looked a lot like a chimpanzee, but she had human-type feet. She was walking upright. As we move forward and the Ice Ages get going around 2.6 million years ago, her descendants turned, or at least her relatives' descendants, evolved into our direct ancestors. And they're very important to the Ice Age because the next group here, called Homo Erectus, they spread north. They started encountering Ice Age conditions, and that's actually what led them to eventually evolve into different types of humans, one of which is us. Others are Denisovans and Neanderthals. Part of what helped them survive, because they don't have big, huge teeth like these, was that they were very, very smart. Just like everybody who's watching this program, because you're smart enough to be here on a computer. This is a 1.5 million year old hand axe This was an actual artifact. This would have been made and used by Homo erectus, an early human ancestor. Now, these guys were impressive because, as you can see, this is a pretty big stone tool. It's heavy. It would have had a very sharp edge, and it was actually used more like a knife. We call it a hand axe, which usually makes you think you're going to chop with it, but believe me, if you make one of these and try to chop down a tree, it doesn't work like an axe. You use it like a meat knife, like a steak knife. And Homo erectus was using this like a steak knife. They were eating large animals. They were hunting and eating things like buffaloes and rhinoceros and even elephants. Now, as the Homo erectus kind of spread out and got into different parts of the world, they continued evolving. Eventually, they evolved into us, and like I said, some other groups like Neanderthals and Denisovans. They developed clothing because even though we're technically an Ice Age creature, we're really well adapted to tropical environments. That's why we like the summer. But winter, we have to bundle up in layers of coats. They had to make their coats out of Ice Age animals. Some of those Ice Age animals they were drawing pictures of and that sort of thing. Their toolkit got a lot more refined, like this here. This is a replica of a stone knife that's only about 22,000 years old. So right in the middle of the last Ice Age. Now, the last Ice Age is really, really interesting because right here in Wisconsin, it had a huge effect on our geography. Up here in Wausau, for example, the glaciers came through and wiped out all of our fossils. They dug up the ground and ground up all the rocks all the way down to what we call the bedrock, which is mostly quartz and granite here, really hard stuff, no fossils. You can't even make stone tools out of it. In other parts of the world, the same kind of thing was happening. Some of our human ancestors, now truly like us, were living right along the edge of those glaciers. Now, this would be sort of an all-purpose tool that pretty much everybody would have some version of. Now, this is a little bit of a fancy tool. So we look here, we get a glimpse of our Ice Age giants. And the neat part on this is the carving on the end here. I can get it to get a good angle on the camera here for you. The carving on the end here is a woolly mammoth. Now, unfortunately, this particular woolly mammoth has been dropped, and his trunk was much longer, so now he's kind of a short-snouted mammoth. But this is a replica of a spear thrower that was carved and used by prehistoric people to hunt, among other things, some of our Ice Age giants. Now we can show you here. Most folks think you're going to face down woolly mammoths and Ice Age giants with something like this. Be a hand-thrown spear with a stone point on the end. And you could if you didn't have any other choice, I suppose, but it wouldn't be your first choice or how our ancestors would want to do it, especially considering the size of some of these animals. The way this works is we have basically a giant arrow, really giant. I think I got space. Here we go. See our bone point on this end. The end of it has a little notch and the feathers, just like a regular arrow. And on the thrower here, our little elephant has a hook, a spur that hooks into the spear. So we hold it like that. And when I go to throw this, get to right about here, let go of it with those two fingers, and then flick my wrist like I'm casting a fishing pole. And I can actually throw this gigantic arrow more than 100 yards, further than the length of a football field. This is a very, very important tool in the last Ice Age for dealing with some of the huge animals that our ancestors were living alongside and actually eating. And a funny little side note, human ancestors ate pretty much everything they came across during the Ice Age. Now, the Ice Age is a little bit of a funny thing. We think, of course, that the whole world is a frozen snowball. Like if we watch the movie Ice Age, where everything's cold and winter and frozen, and you know, mammoths and ground sloths and everybody are wandering around, and it's just winter all the time. Ice Age, it's winter all the time in some places. In Wisconsin, it certainly wasn't. We had glaciers that came all the way down into Wisconsin. They helped to scour out the Great Lakes, like Lake Superior, Lake Michigan, Lake Huron. And in our state, they covered about 3/4 of the state. They left an area in the southwest corner of the state called the Driftless region. There were people that lived there. There were a lot of other animals that lived there, many of which we would think of as being African animals today. Things like horses, camels. We had all kinds of buffalo, moose, elk, deer. We had grizzly bears. We had black bears. We had 2 kinds of elephants. We had woolly mammoths and mastodons, woolly rhinoceros and musk ox, things like that. We had a lot of predators, which is part of why those atlatls, those spear throwers, are really important tools. Now, our ancestors, and indeed early people in Wisconsin, just like us, didn't have big claws or big teeth. They had to deal with things that did. Now, in Wisconsin here today, we have bears, we have black bears. When you're north of Wausau here, we have some wolves, though there's not a whole lot anymore. We got lots of coyotes. If you get way far up north, apparently we get a wolverine come by every once in a while. And we've got cougars, mountain lions. Now, during the last Ice Age, around 15 to 20,000 years ago here in Wisconsin, we had North American lions along with mountain lions. We also had the saber-toothed cat. Now this is a big animal. Now this is the front paw of Esther. And you can see Esther's paw is bigger than my hand. A regular cougar paw is about that big compared to Esther here. Inside the knuckle bones here are the retractable claws of our saber-toothed cat. Now, just like a modern cat, those claws, they kind of pull back. They're almost like a mammal version of the velociraptor claws that kind of hold up off of the ground so they can keep them extra sharp. They're really hooked, and they're really good for grabbing a hold of things. Now, if we had Esther's entire skeleton set up here, you could see that she is a massive cat. A modern African lion is more than twice my size, around 400 pounds for a big male lion. Esther could be 600 pounds, as big as a modern day Wisconsin black bear. And her proportions were different than a regular cat. Modern day cats, if any of you watching have cats at home, they have back legs and front legs that are about the same length. So as they walk along, their stride is very even. Saber-toothed cats actually had longer and more powerful front legs. They had very, very strong shoulders and forearms and really short back legs for an animal that size. In fact, Esther's hind legs are shorter than mine. Now, what that means is she's not very fast, but she's very, very strong. We think that our saber-toothed cats were very sneaky and they were very much ambush predators, but they were big game hunters. Now, because she was so powerful, it's been estimated that a 600-pound cat could actually wrestle down a 2,000-pound buffalo by herself, just by sheer power, by grabbing a hold of it and tackling it to the ground. Now, we had these cats in Wisconsin here. Now, the paws and the front legs are really impressive, but the real dangerous part is up on the front end here. Now, Esther We don't think that they spend a lot of time in groups like modern day lions. They're probably more like tigers. We're really not sure. It's really hard to determine behavior from fossils. And even though they do show up in cave art every once in a while, it's really hard to look at a picture that somebody paints and determine behavior. We would actually have to go back in time and meet them to see if they travel in groups or if they stay solitary like tigers or cougars do today. Now, as I mentioned, Esther is very powerful. She's really strong, like a bodybuilder cat. And when she catches prey, any of those number of animals that we mentioned that would be wandering around the plains and the prairies here in Wisconsin that kind of resemble African savannas today, she doesn't use her claws to kill them like a velociraptor. She actually uses her big fangs here, her saber teeth. Now, it's kind of hard to see on the camera, but the front and back of these teeth, all the way up both sides, are serrated like a steak knife. They're like shark's teeth. Now that means, well, they cut well. So Esther does kind of an interesting thing. Like I said before, she's slow, she's very sneaky, fast over short distances probably, but you know, she's not going to run after things for hours at a time. So she's going to be like your cat at home that sneaks up on your shoes and grabs your shoelace from under the couch, that sort of thing. She's going to pounce out of cover, grab her prey, wrestle it to the ground, and when she's got it held down and she's pinned it, she's going to use these fangs to bite at the neck. Because Esther is a vampire cat. These sharp cutting teeth are going to be used to cut the jugular vein or the windpipe and kill its prey quickly. Now, just like us, when we grow our adult teeth in, Esther cannot regrow these teeth if they break. It's not like a T-Rex or a shark tooth where if she breaks a tooth or gets one knocked out, in a few months it'll just grow back and she'll be fine. She has to be very careful with these teeth. That's why we don't think that she was biting at the back of the neck or even on the skull or the head like a lot of modern cats like lions do. Now, that also means that she's going to tend to leave some leftovers. Now, her jaws can open up way wider than this, up to about here, so that she can actually use those fangs to take a bite. But that doesn't help her a lot for eating. It'd be really hard to take a big bite with these fangs in the way. So if we look at the side view here, you can see her incisors, her front teeth, kind of stick forward a little bit. So as she eats, she's basically eating her meat like you would eat corn on the cob. But because of that, she's going to leave a lot of leftovers. There's pieces of meat, there's things that she just can't fit in her mouth. Stuff especially that's attached to bones that she might risk breaking one of these teeth if she bites down on it too hard. So along with Esther here, there's going to be scavengers. Now, Ice Age Wisconsin's herbivores, plant eaters, were, like I said, a lot like African savanna. Well, the predators weren't all that different. In North America, alongside Esther here, we had another type of lion, the American lion. We had the cougars like today. We had North American hyenas, which were about twice the size of modern day African hyenas. We had black bears and grizzly bears, both still in Wisconsin, plus giant short-faced bears. All of these animals are huge, dangerous predators. Hyenas today can travel in packs of more than 50 animals. They're able to run long distances, which is kind of unusual amongst a lot of large mammals. And they will actually chase down things like wildebeest, run them until they're too tired to fight, and then mob them. Of course, the American lion we think was a lot like a modern African lion. They hunted and traveled in groups and packs, but they were the size of bears. They were 500 to 600 pounds. We had gray wolves like we have today. We had dire wolves, which are half again as big. You can imagine a gray wolf today is around 150 to maybe 200 pounds for a really big wolf. I think a dire wolf could actually get up to 300 pounds. It would stand almost as high as Esther next to me here. Now, we just recently discovered, thanks to actually finding a frozen dire wolf that was melting out of the ice and doing genetic tests, DNA tests, that dire wolves are not related to modern day wolves. They actually split off from modern day wolves and kind of developed into a separate group about the same time that Lucy here separated from the chimpanzees. Now, a pack of dire wolves or even a pack of gray wolves would have been in competition with Esther and in competition with us. Now, the bears would also be a problem. Now, Esther, at 600 pounds and powerful enough to fight a 2,000-pound, a 1-ton bison, a buffalo on her own, is, well, she's a force to be reckoned with. A group of human hunters would have the advantage of stone-tipped spears and torches fired to help scare her off if a saber-toothed cat came after them or tried to get into their cave to have a bite to eat, like, you know, me, and then take a nap. Now, for the bears, our giant short-faced bear is an animal that is huge. Its head is the size of a watermelon, about twice as big as Esther's here. They'd stand 13 feet tall, so they could actually look eye to eye with a Tyrannosaurus Rex. That's so tall that if you're playing basketball at your elementary school with your giant short-faced bear and it decides it wants to slam dunk, it could scoop the ball up with a single paw, dunk that ball without even standing on its toes. They were that huge. Now, Esther here, fortunately, wouldn't have to tangle with those too much, we don't think, but we do sometimes find them in the same kinds of places. Now, Esther and several of these other animals, as I mentioned, we know pretty well from melting ice, from other bones, or even frozen intact individuals are found in the up in the Arctic. But one place that you can probably actually visit, though I don't know if it's open right now with everything being open and closed lately, is the La Brea Tar Pits in California. La Brea Tar Pits is a really neat area. That's where Esther here is from. The tar pits are kind of a strange thing. There's a few places in the world where oil, just like we use in the engine of your car, bubbles up out of the ground in a very, very thick kind of glue sort of substance. They actually call it asphaltum, just like the asphalt streets outside. Well, it's actually what we use to make the asphalt streets outside, but it occurs naturally in some places. It's super sticky. It's a natural glue. The people that lived out there in the Ice Age and the Stone Age actually collected it and used it as glue. My understanding from somebody who's been out there was that there was actually some bubbling up out of the parking lot, and somebody stepped in it. Their shoe got stuck so thoroughly that they just had to cordon off that section of the parking lot and leave the poor fellow's shoe there. Now, this stuff, because it's oil, it's waterproof. So when it rains, the water sits on top of it. It doesn't soak into it, and it looks like a pond. And what happens over time is animals, say like buffaloes or deer, they get thirsty, they see the water, they walk out into the water to take a drink, and they get stuck in this tar, in this glue. Well, when they get stuck, of course, they don't want to be stuck. They start struggling and making a lot of noise. That attracts the attention of predators like Esther. Well, the predators go out there, they get stuck in the glue themselves, and it's kind of like quicksand. The more you fight it, the more you struggle, the more it pulls you in. Eventually, you'll sink completely underneath it. When that happens, it's a preservative. It's antibacterial because it's oil, and it preserves the bones over time. The La Brea Tar Pits, we've found dozens and dozens of saber-toothed cats, giant bears, all kinds of giant ground sloths and deer and so on and so on. Just tons of animals. And it actually formed what we call a predator trap. There's some of these Ice Age giants, these predators would hear the sound of a struggling animal or smell dead things that had been caught there for a while, try to go out and get a bite to eat and get caught themselves. And then as they struggle and get stuck and die, it attracts other predators. We even found bones out there of giant vultures called teratorns. Think like a condor with a 15 or 20-foot wingspan. That's probably the length of your living room from end to end, but a vulture. Now, since we're talking about the California coast over there, we're going to take a little side trip before we come back to Wisconsin and start talking about some real impressive gigantic animals. When we think Ice Age giants, because we think ice age, cold, we usually think about stuff like woolly mammoths, woolly rhinos, and so on. But we oftentimes forget that there's a huge world out there. Our next two Ice Age giants, though they're absolutely, truly giant, you wouldn't find these in Wisconsin. And though people could have seen them at some point, it's not very likely that they interacted. First up, take a look at this guy. This is a single tooth. It is a really, really big tooth. This is actually the largest biting tooth in the entire fossil record. Now there's bigger teeth, there's other tusks, right? Like woolly mammoth tusks are of course bigger, but this is the largest actual biting tooth of any animal in the fossil record. It belongs to a whale called Leviathan. Whales, they started evolving much longer back, much further back than people did, but they were around through the Ice Age, and just like us, they survived it. Leviathan was a predatory whale. Now, this was an animal about 60 feet long, so 2 school buses parked end to end, maybe a little bigger than that even. We take a look at this tooth, can tell us some neat things. Now, it curves backward, and if we turn it this way, it curves inward. Now, Leviathan was a predator, but what that shape of that tooth means is that when it bites down on something, the only way to unhook yourself from those teeth, to pull away without it ripping you up, is actually to go down the throat. It's not a really good escape plan if you're in the mouth of a 60-foot whale. Now, because this tooth is so big, it can tell us some other things. Now, in life, big and heavy, in life here, you would only see this top portion. All the rest of this is anchored down in the gums and in the lower jaw and the upper jaw of the animal. And it's really, really powerful, really, really heavy. Now, just like us, just like Esther, Leviathan, once it gets its teeth grown in, it has to take careful, good care of them. It's not like a T-Rex where it can regrow teeth over and over throughout its life. It's got this one set of teeth. Now, these teeth are massive and huge and reinforced because it uses these teeth to catch its prey and to fight with its prey and to eat its prey. And that puts a lot of force, a lot of pressure on these teeth. It has a very powerful bite. All of its teeth, they're more or less the same size and shape, just like modern orca whales, for example. And well, because of the way it hunts and the size of the prey that it eats, it puts a lot of stress on these teeth. Now, it's feeding, we think, on other large mammals and some large fish. It's possible that Leviathan here actually ate young Megalodon sharks, as they lived side by side together. Now, when this animal hunts its prey, we do believe that they were using sonar, like modern whales, sort of sound that echoes back to tell it where its food is. It's going to swim as fast as it can up to that animal, open those jaws real wide, and clamp down and shake, kind of like a gigantic whale-shaped crocodile. we look here, there's a notch, a little chip kind of worn out of this tooth. That's actually where the tooth from the jaw above kind of crosses over it, chips and grinds the edge off. Not only does that make it sharper, but it works like, what's the word, a perforator. Now on the edge of a piece of notebook paper, when you tear on the dotted line, that's the perforated edge. These teeth make that perforated edge when it bites down on something. So when it bites down and it wriggles its whole self around, those teeth actually tear on that dotted line all the way around and pull out a big chunk of meat. Absolutely glad that these guys can't go on land. Now, of course, Leviathan whales, the owner of this tooth, are extinct today, but we do have some of their descendants still around. This is, we think, a direct ancestor of the modern day sperm whale, which is about the same size but specialized to eat giant squid. I mentioned that this particular giant may have eaten young Megalodon sharks. So we really should talk about the Megalodon too. Megalodons are neat. They are definitely not around anymore. They're completely extinct. And we know they're extinct because even though there have been a few people that have shown up with Megalodon teeth that they claim to be fresh, no one's ever been able to prove that they have a fresh Megalodon tooth. Whenever tests have been done, they come back as negative. There's no DNA left in it because it's fossilized. Now, the last of the Megalodon sharks probably died out around about 50,000 years ago, but it's possible that some of the earliest people to build rafts or canoes or hide boats and actually go out into the ocean to go fishing could have potentially seen one of these sharks. Now imagine if you're out on your fishing boat and you look over the side of your boat and you see a shark that's 60 feet long. It'd be enough to make you want to get out of the water, right? Now, Megalodons are a lot like modern day great whites. You can see the tooth here is about the size of my hand, and that's a really important thing to make note of because modern day sharks, Megalodons, relatives of sharks like stingrays, sea skates, even fish that you can find around where you live, things like catfish or paddlefish that live right here in Wisconsin, they're all cartilaginous fish. What that means is they don't have bones. Because of that, we've never found a Megalodon skeleton. With Leviathan here, we've found skeletons. Of course, whale bones, they're huge, they preserve well. With Megalodon, the cartilage gets eaten by scavengers. When a Megalodon shark was swimming around and it died, maybe a Leviathan bit it in half, it would sink to the bottom. The scavengers come out, things like other sharks, weird little eels called hagfish, or crabs, lobsters, even deep sea isopods. They look like little roly-poly bugs, but they're about the size of footballs. They all eat cartilage right along with all of the soft bits. So what that means is that by the time the remains of the Megalodon get buried and the scavengers have all finished their meals, the only hard parts that are left to fossilize are these teeth. So when we say a Megalodon is, say, 60 feet long, it's actually a guess. We have to compare them to their modern relatives, the great white shark. Its teeth is about a third the size of a Megalodon shark, about that big for a really big one. The biggest one we know of today is a big female. She was tagged, I believe it was 65 years ago off the coast of South Africa. She is 23 feet 5 inches long, and she's still swimming around today. She's eaten a lot of seals. She's a very big fish, but her teeth are about 1/3 the size of a Megalodon shark tooth. So to figure out how big Megalodon is, what we do is take that size tooth and we make it the same size and figure out how big that animal would be. We multiply 23 feet by 3 times, we've got a 70-foot long shark. But we don't actually know. Without a skeleton, it's impossible to say. It could have been a 50-foot long shark with a really big mouth. Now, maybe one of you who's watching this will be the fossil hunter who someday finds a ring of Megalodon shark teeth on the edge of a big depression in the rock that happens to be shaped like a shark? If you do, let us know at Colossal Fossils, because that would be a first. No one's ever found that. But that would be a really good way to figure out just how big that fish is. Now, we'll go ahead and step away from the oceans there and head back to our local fauna. Now, in Wisconsin, I mentioned earlier, the glaciers had come down and created this sort of corner pocket of the state that was untouched, called the Driftless Zone, the Driftless region. And we had a lot of animals, a lot of giant creatures living in the Driftless region, but it was a little different than it is today. A lot of the area was mixed forest and prairie. We would have had, of course, places where people could camp and hang out. And we would have had a lot of almost tundra. It would get warm in the summertime, and actually the summertime heat would melt some of the glaciers, so they'd sort of shrink back a little bit. Probably more like late spring, early fall today than a real hot summer day, but hot enough to melt some ice. All of the dirt, the soil, and the rocks and the minerals that were melted in that ice, or frozen in that ice, would melt and wash down into the prairie and the tundra along the edge of the glacier, where trees wouldn't be able to grow. The grass and the prairie plants would grow really, really big there, because there's a lot of water and a lot of plant food that's kind of coming out of the glacier. And so because of that, we would get some massive herbivores following the edges of the glaciers during the summertime to feed. Now, in Wisconsin here, we had quite a few things. Even today, if you're in the right part of the state and you're a little bit lucky, you can actually find woolly mammoth and mastodon bones. Now, this is a woolly mammoth tooth, and woolly mammoth is a massive, massive animal. Now, I want to mention this real quick. I've had it pointed out to me before that the woolly mammoth tooth here actually kind of looks like a woolly mammoth. He's got his little trunk and over here and his feet, and it kind of does look like a woolly mammoth, but I assure you that's completely by accident. It's not, they don't, grow little woolly mammoths from their teeth or anything like that. A woolly mammoth is a grazer. It spends most of its time out in the open prairies and tundra, eating primarily grass. It eats some other things, but mainly grass. Its close relative mastodon was actually a forest elephant. They were pretty close to the same size. Woolly mammoth was a little bigger. Mastodon's teeth, instead of being flat and looking like the bottom of a tennis shoe, like this here, they actually looked more like our teeth. And mastodons, because they spent so much time in the woods, they ate stuff that grew in the woods. In the winter, especially, they would eat like tree branches and pine cones and conifer needles, things like that. With these big spiky teeth, they were like living wood chippers. They could just mash this stuff up. And we actually discovered just a few years ago from studying coprolite. Coprolite is fossilized poo. Yes, there are actually folks who get paid to study fossilized poo. We found some mastodon coprolites that had nothing in it but wild squash. And I actually determined from studying the coprolites that when late summer, kind of getting into fall, another month or two from now, when the squash would come ripe, the mastodons would come out of the forest and they'd find these patches of these squash and they would just eat them like candy. Imagine eating an entire Halloween jack-o'-lantern pumpkin in one bite. Seeds, stem, rind, stringy stuff inside, the whole thing, just boom. Well, these mastodons would do that until there weren't any left. And well, from one end to the other, there'd be enough squash seeds left that the scientists, some thousands of years later, could tell what they were eating. Our mammoths here, we don't think were quite so versatile that way. They seem to have really, really focused on grass. And what's neat about that is their teeth, the shape of their teeth is pretty unique. Now, they only have 4 teeth. They have 2 molars on the top and 2 molars on the bottom that grind together like this. That sort of tennis shoe texture to the teeth actually works like a whole bunch of teeth all grown into one, so that it shreds up that grass and tears up that fiber so that they can sort of digest it. Woolly mammoths and mastodons, like modern elephants, were not really efficient. About half of what they ate just right through without being digested. So if you were a woolly mammoth hunter, odds are pretty good you could tell where your woolly mammoth was before you could see him. Now, these mammoths, we think they behaved a lot like modern elephants. They had a couple of differences, a couple of neat tricks. Now, before we get talking about our woolly mammoths here, I really want to drive home how big these animals are. I'm going to get a little bit of a bigger piece than just the tooth there, if I can lift it. There we go. This is a lower jawbone, this part, of a woolly mammoth from right here in Wisconsin. Now, I mentioned woolly mammoths had a couple features that made them a little different than modern elephants. Now, of course, elephants and mammoths and mastodons all have the long trunk, the long nose. Modern day elephants' noses are round for the most part, and they're really good for grabbing stuff. The little kind of nubs at the end of their nose, they can use like fingers to pick stuff up. And elephants can even paint. Probably not the wild ones, but at least some of them in the zoos have been taught to paint. Now, mammoths here, because they spend a lot of time out in the snow, their trunks actually evolved to be kind of flattened. And so what they could do is use their trunk like a scoop, like you'd use your hand, and they could swipe snow out of the way so that they could keep eating grass even after snow and ice has started to come in. And their tusks, you look at a picture of a mammoth, or even the mammoths up on my headband here, their tusks are long and curved. And you see them from the front, they actually kind of spiral. They're a little flattened in cross-section. And what they would use those for is like a snow plow. They would take their tusks, put them down into the snow, and shake their head back and forth, side to side, to clear snow out of the way so that they could access grass all winter long. You know, if you're an Ice Age hunter following woolly mammoths, all you have to do after the snow is look for the plowed road. These animals would be clearing out big swaths of prairie to get to the grass and the herbs and the plants that they were eating. Oh. Balance this big fella here. Now, all of that food that they're eating means that they can't stay in one place for very long. A woolly mammoth has to eat about a half ton of food a day, and that's each animal in the herd. Herd of modern elephants can have more than 20 animals. That's a lot of food. That means these mammoths are constantly moving. And it's the same thing with pretty much all of the other herd animals. The buffalo, the antelopes, the horses, the camels, all of these grazing animals would be following along the edge of that glacier, eating up the fresh grass all summer long. And as fall comes in, just like animals today, say like reindeer and caribou, for example, they start to migrate south. They sort of run away from the snowfall. Now, this particular woolly mammoth, since he's got his teeth down here, we can show you just how well they fit together. That would be the chewing mechanism here. He'd spend all day just doing that. Now, this particular woolly mammoth, as I mentioned, he's from Wisconsin, and he's really kind of neat. He is the largest woolly mammoth that we have found in North America. We call him the Heber Mammoth. We've kind of nicknamed this big fella Herbie. Now, Herbie in life was probably more than 4 tons in weight. So that's bigger than the garbage truck that comes by your house once a week. He would have had to eat at least a half ton of food every day. And he stood 16 feet tall. Your average Tyrannosaurus Rex stands about 12 to 14 feet tall. So that means he is taller than a T-Rex. He was a massive, huge animal. His tusks alone are 11 feet long. That's the length of your couch plus another half of a couch. He was an absolutely huge animal. And for me, for the stuff that I study here, what's the neatest thing about him is that early people right here in Wisconsin actually ate him. If you can believe that. Poor fellow was dinner. Now, for most of these animals that we've been talking about, it's kind of unusual to find a complete skeleton. With Herbie, we actually found most of the bones. It's about 85% of the skeleton. And some of those bones actually had cut marks on them from stone tools. Some of the very first people in Wisconsin were using tools that look very much like this to make Herbie into lunch. Now, our Ice Age giants like that, we used to think actually went extinct just because of that exact reason. Now, if our ancestors and the very first people in Wisconsin almost 15,000 years ago are using, their atlatls and their stone-tipped spears to hunt those animals that efficiently, that effectively, that they can hunt the largest woolly mammoth we've found in North America and take it down, protect it from other predators, other scavengers, and eat it. Well, why couldn't they eat all of them? For a very long time, we actually thought that's exactly what happened. We call it the human extinction theory, where they come through and they just eat all of the camels, all of the horses, all of the mammoths, and all of the mastodons, and all of the woolly rhinos. But now we've actually discovered a few things that have kind of changed that idea. Now, the last ice age more or less came to an end around 10 to 12,000 years ago. Right about that time, at 13 to 12,000 years ago, is when woolly mammoths, mastodons, saber-toothed cats, dire wolves, and so on went extinct. Well, what we found out, we call this the Younger Dryas period, there was an asteroid impact, just like the extinction that killed off the dinosaurs, but on a much smaller scale. Just a year before last, satellites discovered a completely unknown crater buried under the glaciers, under the ice in Greenland. The crater is about 19 miles across, and it's associated with a layer of sediment that shows up in Europe and North America as a black line that's about 12,000 years old, right at the end of the reign of the Ice Age giants, that has helium-2, has iridium, has plutonium, it has melt glass. It has things in it that are only associated with asteroid and meteor and comet impacts. Now, of course, that sort of event is very, very rare, but we actually think now that Herbie here and his relatives went extinct because of that particular event in most places. Our last Ice Age giant here, I gotta reach behind me, is actually not quite giant. There was a few places over in Siberia and the Bering Sea where our woolly mammoths actually survived up to about 5,000 years ago. This is a tooth of a woolly mammoth, but it's a pygmy mammoth. Its tooth is less than half the size of our full-sized mammoth tooth. Now, on this island, our woolly mammoths probably wandered out there on ice floes in the winter, and then when summer came in and the ice melted and they had enough food, they just kind of stayed there. Over time, they got smaller and smaller because the island wasn't a very big place. And well, by the time they finally ran out of food and ran out of genetic diversity and went extinct, they were tiny. They were about the size of a horse. Looked exactly like a regular woolly mammoth, but fun-sized. Now, they ate, they behaved, they acted, we think, just like typical modern woolly mammoths. It's certainly possible that people found them at some point or knew they were there, but they were tiny little woolly mammoths that just happened to survive the extinction that took the rest of them and made it almost into modern times. Now, this process, we call it island dwarfism, and we actually see it happen in other species too. There's even a human ancestor called Homo floresiensis. That's sort of another ice age relative of ours that you might have heard of them, called the Hobbit people. They got isolated out in Indonesian islands, and they were only about 3 feet tall, but they used stone tools and fire just like we do, or did. So don't think that just because an ice age giant starts out giant that they have to stay that way, or for that matter, because they start out small that they have to stay that way either. Well, I want to thank everybody for joining us, and hopefully you learned a lot and well, found some of the ice age giants and creatures here from the last couple thousand years to be as interesting as I think they are.